Okay, let's look at the traditional method for hypothesis testing. This is just an overview. It's not specifics. It's an overview. This is from Chapter 8 in our textbook. There are 5 steps for the traditional method. Number 1, state the hypothesis and identify the claim. Number 2, find the critical value from the appropriate table. Number 3, compute the test value. Number 4, make the decision to either reject the null or do not reject the null. We're only going to have those 2 choices. Number 5, summarize the results. In our class, we're going to stick to 2 choices. There is enough evidence to support the claim, or there is not enough evidence to support the claim. Now let's break these up a little. So for step 1, you're going to have to state the null h sub 0, which is always mu equals. Okay, you'll see it in all 3 cases. And I'm just using means or averages right now. We're not going to talk about chi-squared yet. Okay. You also have to state the alternative. If they say in the problem something that means less than, you're going to shade your curve to the left. If they say in the problem something that means more than or greater than, you're going to shade your curve to the right. Now the last one is a little bit different. If they say in the problem that something differs, then they are claiming that it is not equal to. Okay, so if you see the word differs, that means not equal to. If you just see the word is, they're saying something is, that would be they are claiming the equal to. Okay, so normally you either see greater than, less than, you know what it is. If you see the word differs, then you know it's not equal to, or they may say not equal to. If they don't say any of those words, go back and look. They're probably saying, okay, we believe that it is this. Then they are claiming the equal to. Let's look at the pictures. When it is less than, then you're going to shade to the left. When it is greater than, you're going to shade to the right. Probably the hardest one to do is the not equal to, because that is a two-tailed test. Anytime it is equal to or not equal to that they're claiming, your curve should look like this. Now the next step, step 2, says find the critical value from the appropriate table. If they're talking about averages or means, and your sample size is greater than or equal to 30, you're going to use the z-table. We'll look at that in a second. If they are talking about averages or means, and your sample size is less than 30, you're going to use the t-table for the critical value. If they are talking about proportions or percentages, you're going to use the z-table for the critical value. And lastly, if they're not talking about means or averages at all, and their hypothesis has to do strictly with standard deviation or variance, then you're going to use the chi-squared table. And by the way, the chi symbol looks like that. Okay, so the chi-squared table. Let's take a quick look at those tables. This is not in depth. We'll do that in examples later. So the first table, the z-table. This is the z-table. There's a negative side and a positive side, okay? You have these tables in the classroom. I know these are small, but we're using them for an example. So remember, we use this table when we have sample size greater than or equal to 30, or we're doing proportions or percentages, okay? See, this table reads from the left. So if your curve is shaded to the left and your alpha is, let's say, 0.05, okay, remember we would put the alpha in here, and I'll erase this in a second. Okay, we add a couple of zeros so that it looks like the table. We have 4 digits, and we want to go up here and we want to find the closest thing to that 500 in the table. Okay, now I picked a bad number because you guys know that 500 would be half of it. So let's change that. Let's do 0.01 so that this works out like I wanted it to. Let's change this to 0.01. If your alpha was 0.01, we want the closest thing to 100. So you go up here to the chart. The closest thing happens to be right here. Okay, so that happens at negative 2.33. Okay, negative 2.33. Now, let's say your table is shaded the other way. Your curve is shaded the other way. Okay. I'll just do a sloppy one here. If it's shaded that way, then remember you have to do 1 minus. So I would have to do 1 minus 0.01 and look up the closest thing to 0.9900. And that, of course, would be on this side. Okay. One last little reminder about this one, let's erase my ugly one, is that if there's a tie, if one is, like this one is one that's used all the time. So let's say we're doing 9,500. If one is 5 below and one is 5 above, this textbook says go to the right. The textbook that I use in my class doesn't say average them, it says go to the right. That would be 1.65. You always go right, okay? If your sample size is less than 30, this is the chart we use for the t distribution. Remember, degrees of freedom is n minus 1. That's what your degrees of freedom is. So if your sample size is 10, you should be at 9. If your sample size is 20, you should be at 19. If your sample size is 35, you shouldn't be on this chart. Because remember, this is sample sizes less than 30. Okay, so we want sample sizes less than 30 on this chart. Also, we talked about this. One-tailed would be for the greater than or less than. And then for not equal to, they have a two tails. With the previous chart, if it is two-tailed, you had to split the alpha. Remember, we talked about that in class. With this chart, because they have a two tails, you don't have to split the alpha. The one thing we discussed in class that I did not like, though, is if it is left-tailed, you have to remember to put the negative in the front. So you look for your degrees of freedom, you go across to your alpha. If you go down, you have to remember if it's left-tailed, make that negative 2.12. But if it's two-tailed, it's easier to use this chart. And the last one, this is our chi-squared distribution. It also uses degrees of freedom, which is n minus 1. And we also talked about how to get these numbers on the top to figure those out. Okay, so that's just a quick overview of step 2. Let's talk about step 3. Step 3 has to do with the test value. You have a formula sheet, and these are on your formula sheet. Okay, so this is the formula right here if n is greater than or equal to 30. Okay, now what I don't like is the way they did this. This should be on a new line. Okay, if n is less than 30, then you use the t-test. Okay, so remember, n is less than 30, you're using this one. Now you will notice, you guys, they're the same. They just use a different symbol. This is the population standard deviation. This is a sample. It's a smaller sample. It still means standard deviation. So the formulas don't change, but you need to be on the t-chart for your critical value. Okay. If you're using a proportion, then you use this one. Okay. So n is greater than or equal to 30, this one. N is less than 30, you're using t-test. If you're using a proportion, you're using this one with p hat. Remember, p hat is where they tell you something like 2 out of 3. And you would do 2 divided by 3 to get your p hat. And if they are giving you variance and standard deviation, you are using this fourth formula. Okay. Notice that on top is the variance of the sample. If they give you standard deviation, you have to square it. If they give you variance, you just plug it in. On the bottom is the variance of the population. If they give you variance, you just plug it in. If they give you standard deviation, you have to square it. Step 4 never changes. It is either reject the null or do not reject the null. So let's look at this and do a couple of cases. The null is always the white area. Always the white area. Okay, so I'm going to give you a couple of examples here. If my test value is here, what would I do? If my test value is over here, what would I do? Let's talk about those two cases. So on this first one, if my test value is over here in the white area, the white area is not empty, so I put do not reject the null. Okay, let's look at this next one. I look at the white area. It is empty. Anytime the white area is empty, we put reject the null. That's your two choices. If the white area is not empty, then you put do not reject the null. If the white area is empty, you put reject the null. Now, step 5. The claim can be the white or the shaded. So step 5 is always about the claim. Okay, always about the claim. So on this one, let's look at this one. If they claimed the shaded area, okay, and this one says they claimed the white area, because remember the top one is white. That's the white area of the curve. okay? And the bottom one is the shaded. H sub 1 is always the shaded area of the curve, okay? So in this one, they claim the shaded. So let me get a different color here. If my test value is here, okay, and they claimed the shaded, I have two choices. There is enough evidence to support the claim, or there is not enough evidence to support the claim. My claim is the shaded. Is my evidence there? No, my evidence is the pink line. So on this one, I would put there is not enough evidence to support the claim. Okay, that would be for this one. Let me move that over out of the way a little bit. So for this one, they claimed the shaded, the evidence is not there. Now let's say I did the exact same thing over here. Okay, so suppose my test value was right there. Let's look at this one. They claimed the white area. So my test value is in the white area. So for this one, I would say, I'll put it down here, there is enough evidence to support the claim. Because it really depends on whether they claimed the white area or the shaded. So step 4 is always about the white area. Step 5 depends on the claim. If they claim the shaded area, your evidence needs to be in the shaded area. This one is not, so there was not enough evidence to support the claim. Over here, they claimed the white area. My evidence needs to be in the white area, and it was. So there is enough evidence to support the claim. So hopefully this little overview helped you. I'll try to do some more specific examples later, but this one should help you out.